The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Thanks for joining us for today's TopSolid webinar featuring some of the what's new features for the 2020 version for 4 and 5 axis machining. We're just going to give people a few more seconds to get logged in here and then we'll fire off. Just as a reminder, I'm here with my TopSolid USA team. They are monitoring the questions section. So if you have any questions, by all means, type them into the question section and we'll do our best to answer them live either during the presentation or at the end of the presentation. So with that said, why don't we just get started? So the first improvement we're going to talk about is in the 4-axis continuous world. If you look at the part on the screen, and I'm just going to make sure that I have this turned on. I do, perfect. So you guys are seeing it. If you look at the part on the screen, this part is clearly on a 4-axis mill, right? But if we look at the feature here, this feature is not really a radial feature, is it? Because this feature is not passing through the center of rotation here. So to show you what I mean, I have a side milling operation on here. And if we watch the toolpath simulation of that, we'll bring that in. And if you look, your tool axis is of course passing through the center of rotation like it should be, but it's violating the part. Why? Because radial toolpaths have rules they have to follow, and this geometry does not match those rules. So what we wanted to do was still make it so you could machine this type of feature on a 4-axis mill. So what we did is we enabled swarf machining. So first thing to understand about this is you must own the 5-axis continuous module to use this, but then you can activate swarf machining or 5-axis contouring on a 4-axis only machine. And in doing so, the toolpath will shift and keep the tool tangent to the feature. And if we watch the simulation, and I'll come back in there to show you the settings, but if we watch the simulation here, let me slow it down a little bit. Okay, that's a little too much. Now you can see that tool is staying exactly tangent to the face of the part. We want to see that with the machine on because it's sometimes more interesting that way. Now you can see, and if we look at our axis motion here, everything is shifting the way it's supposed to. Okay, now let's take a look at the operation really quick itself. And if we go in here, so first of all, the kind of machining on this sample, because it's just a simple one, I'm just using faces, okay? But you can use curves, you can use all 3 modes, in fact. Here, the geometry selected is that face. That's the face we want to machine. And then to make sure that we don't violate the bottom, we're going to turn on a check surface method of faces. And then we select this bottom face right here. That's it. And now you have 5-axis swarfing. To have a look at the differences between the two in Verify, let's go ahead and go into Verify there. So I'm going to do this without the machine just to win some time. So if I go here, you can see that the tool is turning red because it is violating, as you saw in the regular simulation. If we go here, of course, it's going to show it bleeding, which of course it is because we really violated it. If you go to your clash list, of course, you can put the tool in whatever point position you want, have a look at it, and off you go. If we look at the swarf machining in Verify, let's do that. And we hit play there. Here you can see, nice clean motion. And if we go to here, perfect. Okay. So again, if you're a 5-axis user, you have access to this in 4-axis now. Fantastic. If you're a 4-axis continuous only user and you do parts like this, you might consider upgrading to 5-axis to gain access to this new algorithm. Alrighty, let's move on. So next thing I want to do is I'm going to talk about an improvement to 4-axis radial roughing and radial finishing on head-head machines. And what I mean by that, if I go to my equipment and test axes, this is a 5-axis machine. Okay, so you have a tilt this way, and then the C-axis is in the head this way. Okay, so all the rotations are in the head. This is usually found on big gantry machines like this. So in the past, it was not possible to drive 4-axis radial roughing or radial finishing on these types of machines because the center of rotation is always changing, right? So now, as you can see, we've solved that problem. Now, how do we solve it? Let's have a look. If we go into the radial roughing, again, for those of you who aren't familiar with this, it's the 45D tab. It's the first icon. Let's zoom up on things so we can see. And you go into multi-axis. In multi-axis, it's asking you now for a wrapped axis. So here, you had to either define ahead of time or using this, define the center of rotation for the 4-axis feature. That's it. Other than that, it acts just like it would any other time you're using this. Okay. If we look at the radial finishing, same concept. So here I'm using the head to just go up and down and index around the part. If we look at this kind of straight on, you'll see it kind of index over every 2 degrees. So it's just a way to finish parts in 4-axis radial, however you want to look at it. Okay. Again, same feature because it's a cousin to this command. The only thing you need to worry about on a head machine is you have to define that wrapping axis. That's it. All right, cool. So let's move on to 5-axis. Now, before I get into 5-axis continuous stuff, I want to talk about a new improvement to managing WCSs. So this one I think is really, really interesting. Here we're on a 5-axis quasar machine. If we look at this, let's go look at the kinematics just so we all get familiar with it. The tilt axis, we can tilt that far that way, only that far that way. Okay, so there's definitely some rotary limits. And now let's go look at, how about this side milling right there? Okay, let me go turn off this other toolpath so it's not in our way. So first off, if we zoom way up on this, I'm side milling this face just to kind of show you. I have that face selected and off I go to side mill it. Now, in 7.13 or last year's version and before, in order to modify your WCS solution, you had to come in here and you could say, no, I want to tilt the other way, right? But what's interesting is there's actually significantly more angular solutions that are available. You have to click up here to find them. For example, I could switch to this set of angular solutions, or this, right? But in doing so, I'm kind of guessing because it's hard to follow. Now, one thing I want to point out is you're seeing as I'm mousing over, the software is throwing the table and the part in the right position. The reason you're seeing that is first and foremost, I have display machine preview and position active. Most times when I'm doing 5-axis positional, even sometimes 4-axis positional, or I'm on a B-axis mill turn machine, I want to see in real time my angular solution sets. I want to see the part rotated. I want to see everything where it's supposed to be. So make sure you have that option turned on. Now, from there, none of these are the improvement yet. I'm going to show you a faster way to switch between WCSs. There's a nice little button here. Let me see if I have my super zoom turned on. I do. It's right here. Okay. This little button will show or hide every WCS solution that the software found to machine the face selected. Okay. And what's really cool about it is these are all selectable. For example, the one that's the biggest, that's what we're using right now. But what if I want to use this one? I can just click on it and instantly now I'm machining that way. I want to go back and now I'm machining this way. What happens if I choose this angular solution? Now it recalculates everything and I'm machining this face. Let me turn off the tool so I can point better. I'm actually machining this face with side milling now. It's kind of cool. Okay. And again, you have multiple angular solutions there that you can pick on. I want to be back to there. What happens if I pick this one? It's going to recalculate. And now we're going to machine, well, with the part more set vertically, okay? And if I turn my tool back on, obviously this isn't going to work, at least not all the way down. That's what all the red is showing me. It's showing me collisions, right? But at the end of the day, this is a significantly faster and simpler way to switch between WCSs, and you don't have to worry about going into any menus or any dialog boxes. Just have this little baby turned on, and off you go. Cool. All right, let's move on. All right, so the next thing I'm going to show, I have this in my 5-axis continuous samples. It has nothing to do with 5-axis continuous, okay? And if I'm being honest, this isn't even a new improvement. What I want to show you guys is how to deal with manual stock updates, okay? Why? Maybe you're dealing with some really, really complex parts. Maybe they have hundreds and hundreds of operations, and you want to have the power of updated stock models, but you don't want it to slow down your recalculation times. So I'm going to teach you how you can cheat a little bit to win on recalculation times, but still have the power of an updated stock model. Okay, let's have a look. If I look at this part, and let me turn on the whole machine. Again, I'm on a 5-axis machine. I think I'm on the same quasar that we were on before. Cool. If we look at this machine, you can see I have an updated stock model for my roughing and for a 5-axis sweeping. Okay, but if you notice, I have two operations in here called stock modification operations. If I roll back before them, so here's my roughing, and you can see that with my roughing, and I'm using boost milling, by the way, on this roughing, okay? We see there, and I go down one operation. Now there's my stock modification, but this is an actual operation where I am choosing the stock model that I want to use, okay? Now, let's look at how all of this actually works. I'm going to delete these operations, okay? And for now, I'm not going to worry about recalculating anything. What I want to do is I'm going to come into my entities tree, and I'm going to go to my faceted shapes here, and I'm going to wipe all of these out, and then I'm going to go back to my NC operations. First thing I want to do is I want to go run verify on this roughing. Okay, so it's going to load it into verification. I believe I had machine simulation turned on, so I'm going to turn that off as well. And here I'm going to use an improvement made last year in Verify to make this animation a little bit faster. So you have two modes, remember, down here for animated. You have that mode, and then you click it again, and you have a higher speed mode, which I can even crank up and go faster with, right? And the reason I like this mode is because this is giving you the quality of animation, but it's doing it at a really, really fast pace. Now, from here, I'm going to right-click on this model. I'm going to go down here to Save Stock. When I do that, I'm going to do two things. First, I'm going to set it to the absolute frame, and this is super important. And then I'm going to call this what this is. This is roughing. Green check. The software is going to save a faceted model of that stock condition in your entities tree for you. So if I go to my faceted shapes here, there it is. Okay. Now, what I can do with this is under the additional tab, I can go here to stock modification. And oops, let me back up. I want to do this prior to my sweeping. And I'm going to go to stock modification. I'm going to click this very first option here. I'll go to my entities tree, and I'm going to choose roughing because that's the stock I want to now use. And when I validate, you'll notice that the stock model, oops, get rid of that. If I go back to here, you'll notice this operation is here. But if you notice, the stock model is now up to date based on the last verification of that. Now, why would you do this? Maybe you're going to tweak a few more things here. Maybe it's feeds and speeds. Maybe it's, some lead in lead outs, but stuff that's not really affecting the updated stock model. But if you were updating the stock through roughing, because you made those little tweaks, the software during a recalc would want to recalculate the stock update. Whereas doing it this way, this is a dumb model. You're saying this is good enough moving forward to everything else. So you're saving a significant amount of time potentially on that update. If I go down to here, okay, and let's go ahead and just execute this once, just so that it's recalculated. This is a little 5-axis cut just for fun. And we're going to go do the same thing. Again, this is not really an improvement. I think this is just one of those commands people don't really know about. Okay. Now from there, let's go ahead and verify that. One of the advantages of having that stock update modification there is because of order of operations, it's going to come in already set here as well. And now I'm going to do the same thing. I'm going to hit play. I'm on this fast mode, right? So I'm just going to hit the speed up button here. And again, it's 5-axis. It's going to take 20 seconds, 30 seconds to get through the animation. And you can use turbo mode as well. It's up to you. I like using animation mode when the part's not too crazy because the model is more accurate. Okay, so this will be done here in about probably another 10 seconds. If we zoom up, you can see just how accurate the model is this way. It's quite nice. Okay, so that's done. Let's go ahead and save that stock. And I'm going to, again, set that to the absolute frame. And I'm going to set this as 5-axis sweep. Cool. And then from there, we'll go ahead and do another stock modification. Come into here, go to my entities, choose my 5-axis sweep, green check, and you'll see that model gets replaced by the new model. And off you go. So this puts you in the driver's seat. You don't have to be in 5-axis to do this, guys. You can do this in 3-axis. You can do this in anywhere, okay? So after that, you keep on going. You know, you could do 2, 3, 4, 5 operations, run the verify, get the updated stock, save it off. Now, one other thing that I will tell you that you can do with this is use these stock models on repositionings, okay? So if you wanted to use this stock model on a repositioning, instead of repositioning from here because you want to break that link to this operation, you could totally do that as well. Remember, you have a lovely command here called entity copy and entity paste. So you could entity copy the 5-axis sweeping stock model, go into a machine part setup file and paste it in there. And then use that as your stock model for the next operation. And if you ever have to update it, you can always entity copy a new stock model into that MPS file and move on. Perhaps in an upcoming webinar, I will show you guys how to do that one as well. Okay, but this is just food for thought. So hopefully you like this little bonus trick, and we will move on to 5-axis continuous. All right, so let's go to tilting optimization and talk about that for a moment. So in this sample, we just kind of want to talk about something that happens in 5-axis continuous milling, okay? If I go and run this simulation, you're going to see pretty fast here what the problem is. And it's not a problem, it's a problem. Depending on the machine and how fast you're cutting the material, you can get dwell marks out of this. This would be better with the machine turned on, so let's do it that way. I'm going to speed this up. All right, so if we watch this cut, we're keeping an angle here, and you see how the tool is spinning the C-axis in crazy ways, okay? And the reason it's doing that is because there is a slight deviation between normals as you go around the corner, and so it thinks, oh, I have to go all the way around to the other side, okay? And that's just not always the case. Sometimes it is, okay? But when it's a slight deviation in normals, it would be cooler if we could control that to keep the part a little more stable during a 5-axis continuous cut. So within the sweeping command, you can now do that. So I'm just going to go into sweeping. Just to give you some background on this toolpath, I am actually programming on a reference surface because inside here is multiple surfaces. Okay, so this is a single reference surface. that I am using projection with. So I have my projection type set to normal vector, so it's normal to the surface that I selected to machine, which means it'll project the tool path onto the actual part. Okay. From there, we'll go into multi-axis. We'll have a look at those settings. And then here is where the new improvement is. There's a new command here called manage undefined vector position. You activate that. Vector to take into account, this is just how you want to measure the vector. And you can see I've selected this cylindrical face here. So I'm measuring a vertical vector. And I'm saying the minimum deviation angle is 2 degrees. So that's it. If I click OK and I let it recalculate, you're going to see a couple of really interesting things here. First, you're going to see a lot of these rapids just go away. Okay, so now it's a much more consistent toolpath strategy. And if we go and run the simulation, you'll see instantly where the improvement is. Let's speed up here a little bit. There we go. And notice as we're spinning around, the angular change of C is very, very slight. So it's just a better way to control how we transition from vector to vector when we're doing this 5-axis cut. So again, if you do a lot of 5-axis continuous toolpaths, I think you'll like this improvement. It should also help improve surface finish quality on your parts. Okay. Alrighty. All right, so we have one more cool improvement to talk about today. We're going to go into here. This one is called 5-axis sweeping limitation with distance. This is kind of an interesting one. I'm going to show you 2 little improvements. Okay. First improvement. I'm going to have a run the simulation here. Okay. I'm using a face mill on here. Okay. And the face mill is not fully supported by the algorithm. We'll talk about that in a sec. Next, if you notice, it's kind of hard to see, but my arc-on is inverted. Okay. Why? Maybe this part is so big you don't have room to have the tool come in off the part this way, but you still want to ease the tool into the surface. Okay, so we'll talk about that. Let's speed this up and let's maybe look at this straight on, because where the challenge comes in is when this tool starts coming down here. Let's slow this down some so you can see it. This is going to come in, right? And it's going to perfectly stop and step over and move back. Okay, so if we have a look at this tool path, you see your inverted arc and you see that it's stopping short of that face. Now, let's have a look at how to build this. So I'm going to start from scratch. I'm going to go to sweeping. First thing I want to do here, I'm going to change to cut along the length of the surface. And I want to go grab my face mill. Now, I mentioned this earlier. Remember, I said we're using a tool that's not fully supported by the algorithm. Just as a reminder to everyone out there, when you're using TopSolid, the tools you see in your list of tools here are the tools that are fully supported by the algorithm. If you expand this, all these other tools are partially supported. And by partially supported, it means please run verify, please check your work, because we're not checking all of the features of those partially supported tools. Okay, by expanding that, I can expose my face mill. And I see one of you said that's either a big part or a very small face mill. It's a big part. It's a 150 millimeter face mill. So we even give you a warning when you select it. This type of tool is not adapted for the operation. Okay. Now, let's go here. First thing I want to set is my step over. I'm going to set that at 40 millimeters because, again, I'm taking a big cutter and we're just kind of running back and forth along there. And then let's go into our settings. We'll go to our plunging retract options. Here I'm on tangent arc. If I type in a big value, for example, 100 millimeters here, it's going to be a normal arc. Here's the magic trick. I'm going to type minus 100 millimeters. and that is going to invert the arc. Okay? Again, this is done for extreme cases where you might be violating the travel limits of the machine, and the only way to do it would be to come on tangently. Let me float this way. Come on tangently this way, so you ease the tool in, and then you cut, because if you came in tangently this way, you would over travel the machine, for example. Okay? So that's step one. Let's just have a look at that. You know what? Let's turn on multi-axis right away as well. Okay, good enough. We just want to keep the tool perpendicular. So we'll click OK. Alrighty. And here we get to see that simulation, and there is that inverted arc condition again. Okay. And of course, we have a violation. Makes sense. Our violation's right here because by default in sweeping, and this came up in a support ticket the other day, by default in sweeping, we don't automatically check adjacent faces. Because again, the idea of sweeping is you're focusing on a single surface, okay? So if you want to take into consideration other faces, you have to tell the software. So it's all about giving you lots of control. So here we go. If I come in here to my geometry, this is where the next improvement is. Typically, all you would do is check automatic check faces. But if you notice, they're grayed out. The reason they're grayed out is because this tool is not adapted to this operation, meaning it's not fully supported. So we can't automatically check for you. But to make it so that you can truly use any tool out there, we want to put you in the driver's seat and give you a little bit more control. So here's what you do. There is a new command here called enable computing with a distance. If I select that command, by default, it's set to the diameter of the tool, or pardon me, the radius of the tool. So it's diameter of the tool times 50%. Okay? Once you've activated that, then you can also activate trimming surfaces. So I can go here and say, I would like to trim the toolpath by that. And now if I click OK, you can see that the toolpath has been trimmed back properly. Now let's have a look at this. Let's go to maybe two views. And in this view, I want to look straight at it. We can zoom up on that area. And in this view, we can be zoomed up there. Let's go ahead and run our simulation. Let's sneak up on us here. So here you can see it's coming down. Again, you can see that tool is staying perpendicular. And here, it gets right to that edge, steps over, and comes back. Now, if you wanted a little bit extra clearance there because you know there's some material here and you don't want to drive the side of a shell mill into that material, which I think makes sense, you go to your geometry, and with the trimming offset, you can add a value here. Like if I add 20 millimeters, we'll click OK. And again, watch this toolpath here. I'll leave my cursor on it so you can see. You see how it's now shifted from there. And if we watch that simulation one more time, and we'll speed up a little bit, get it to where we see the part. So now it's going to stop with the edge 20 millimeters shy of that face. And off you go. Okay, so there are lots of little improvements like that. Okay, and when it comes to using sweeping, again, sweeping is a toolpath strategy where it's about giving you control to try to do what you want to do. We're not looking at all the surrounding faces, we're not looking at anything, but we want to give you the ability to get the toolpath and manipulate the toolpath to do what it is you want to do. Okay, so with that, there is a that's it for the 4 and 5 axis major improvements. If there's any specific questions I can help with that you want to share with us right now, by all means, go ahead and ask. Otherwise, we thank you guys for attending, and we'll look forward to seeing you next week. Just as a reminder, next week is going to be mill turn improvements, and we're going to also be showcasing the new Swiss turning module.
Hey, Bill, can you circle back to the original SWRF, 4D SWRF? There were a handful of people that logged in after you went through that I think would benefit from seeing.
This one here?
Yes, sir.
Okay. You want me to just go through it one more time?
Yeah.
Okay.
I said a handful of 4-axis users I've noticed logged in after you were finished with that example.
Okay, real quick, cool. So we'll go through this 4-axis swarf milling again really fast. So here is here's the challenge, right? So you have a part like this, and you have a feature like this, and all you have is a 4-axis mill. The problem is this feature is not a real radial feature. It's not exactly perpendicular. And let me go look down the axis, it'll be a little easier. It's not perpendicular to the center of rotation, is it? And because it's not perpendicular, that means it's not 4-axis radial machinable. Let's have a look. If I run the simulation here, you can see my tool is exactly perpendicular to the center of rotation because that's what 4-axis radial does. But you can see it's violating the heck out of the part, or it's re-engineering the part for your customer. And hopefully they have a good sense of humor. But at the end of the day, you still have to machine that feature, right? So by the way, just so you see how this was done, I'm just using standard side milling. I selected the side face there. I went into multi-axis. It's on 4-axis radial. That's it. No magic. Okay? Again, not really a 4-axis radial feature. If you own the 5-axis continuous module, where the improvement is this year is you can activate either swarf machining or 5-axis contouring on a 4-axis only machine. In this case, for the swarfing, I chose face selection method. If I go into my geometry, the face to machine is that face. Makes sense. Okay. I added some check surfaces here as well, and that's this bottom face right here, so the tool doesn't violate that face. That's it. And if we watch the simulation of that, here the software is going to manage properly offsetting the tool and keeping that tool tangent to that surface the entire time. Okay. If we go look at the two and verify, just to have a quick peek at them, again, we'll go into here, and I'm going to do this without simulation just to win some time, right? And we'll hit play. Here you can see it's telling us we're violating the part. We have lots of collisions. If we go here and run a comparison, of course, we're going to see that blood red color. You can list all the gouges if you want, but you saw in the other simulation anyways that, the tool just can't reach there because it's 4-axis radial. So if we go and look at this as 4-axis swarf machining, and we hit play there, now you can see it's not only nice clean motion, but the model is not being violated. So if we speed that up a little bit, no collision, and we come into here, and you have a nicely cut part in 4-axis continuous using that 5-axis mode. So I see your question here, Kevin. It appears that the only thing the side mill operation needs to do is offset the cutter when doing the side milling simulation. It appears to stay constant with the surface. So yes, but as I mentioned earlier, when you're doing true radial machining, the tool has to be perpendicular to the center of rotation, and even offsetting the tool would not cut this specific feature because this feature is evolving, first of all. So it's a ever-changing angle, and it's offset. It's not offset perpendicular to rotation. It is offset parallel this way. Okay, so it is it's not a radial machinable feature, is the best I can tell you. Okay, cool. Are there any other questions that I can help? Otherwise, we'll say thank you to everybody for attending today. And again, we look forward to seeing you next Friday at our mill turn webinar. I'll also do one more plug that we have decided to continue doing webinars every Friday for the rest of the year. They will be specialized webinars, and we'll be releasing a list of those by next week. So with that said, everyone have a great weekend. I say take the rest of the day off because, well, I want to. And again, we'll see you guys next week. Oh, and yes, these are all online. So if you go to the blog.topsolid.com and click on the What's New link, all the recordings for these webinars will be found there. Have a nice weekend, everybody.